In the last video, we looked at how to get the bending strength of a beam when it's continuously laterally supported using the AISC tables. In this video, we'll look at a little more general situation when the beam is not continuously laterally supported and we know what the unbraced length is. Remember from the video on lateral torsional buckling that under such circumstances, the flexural strength of the beam is given by this curve in the AISC manual, for which there are equations. But under some special circumstances, the manual also has charts such as this that give the bending strength, specifically when we use a type of steel for which the yield stress is 50 ksi, and we use this factor CB equals 1. Under these circumstances, we can use these charts instead of certain more complex design equations. So if we look at this chart, this curve, which corresponds to the W8 by 10 section, we see that this is just like the chart in the curve in the previous page. And for example, if we had an unbraced length of 8 feet, we could see that the strength is 21 kip feet. That's how we read off these curves. More generally, suppose we have an unbraced length of 10 feet. And we wish a moment capacity and we wish to find what section will do the job. We can go and look over here. So we have an unbraced length of 10 feet and we want a moment capacity of 2,420 kip feet. So it looks like a W36 by 170 section will do the job. However, we see that we bump into a dotted line. When we bump into a dotted line, what that means is there is a lighter section which, for the same unbraced length, will have at least that much moment capacity. So in this case, we might as well use W40 by 167, which is a lighter section but has a larger capacity for the same unbraced length. That's how we read the charts. Now, this chart kind of looked like the chart in this page and was easy to understand, whereas these charts are not so obvious. So just to understand how these charts work, let's put a few pages of these charts together and see what it looks like. For a section such as W8 by 10, the entire available moment strength versus unbraced length curve is contained in one page. So for example, if the unbraced length is 8 feet, then we can determine the available moment strength is about 21 kip feet. On the other hand, if we look at a section like the W12 by 45, the entire curve is not in one page. So let's take all the pages that contain this section and piece them together to see the overall shape of the strength curve. So let's take this page. And then let's track this section . So we look at the unbraced length and the strength, and then we find that unbraced length and strength on the next page and track this section. paste that and line it up with the end of the previous segment of the curve. And then trace it again. We pick up the next piece of it and line it up. So we can now trace the strength curve for the W12 by 45 section. We see that it spans multiple pages, but ultimately, if we zoom back out and look at it, it's the same shape of curve as we saw before. Also, notice that the curve terminates, in this case, at an unbraced length of 30 feet. And in these charts, the unbraced length goes at least to a span to depth ratio of 30.